the Big Bang no longer means what it used to. As we gain new knowledge, our scientific picture of how the universe works must evolve. This is a feature of the Big Bang, not a bug. If there's one hallmark inherent to science, it's that our understanding of how the universe works is always open to revision in the face of new evidence. Whenever our prevailing picture of reality, including the rules it plays by, the physical contents of a system, and how it evolved from its initial conditions to the present time, gets challenged by new experimental or observational data, we must open our minds to changing our conceptual picture of the cosmos. This has happened many times since the dawn of the 20th century, and the words we use to describe our universe have shifted in meaning as our understanding has evolved. Yet, there are always those who cling to the old definitions, much like linguistic prescriptivists, who refuse to acknowledge that these changes have occurred. But unlike the evolution of colloquial language, which is largely arbitrary, the evolution of scientific terms must reflect our current understanding of reality. Whenever we talk about the origin of our universe, the term the Big Bang comes to mind. But our understanding of our cosmic origins have evolved tremendously since the idea that our universe even had an origin, scientifically, was first put forth. Here's how to resolve the confusion and bring you up to speed on what the Big Bang originally meant versus what it means today. The first time the phrase, the Big Bang, was uttered was over 20 years after the idea was first described. In fact, the term itself comes from one of the theory's greatest detractors, Fred Hoyle, who was a staunch advocate of the rival idea of a steady-state cosmology. In 1949, he appeared on BBC Radio and advocated for what he called the perfect cosmological principle, the notion that the universe was homogeneous in both space and time, meaning that any observer not only anywhere but anywhen would perceive the universe to be in the same cosmic state. He went on to deride the opposing notion as a hypothesis that all matter of the universe was created in one Big Bang at a particular time in the remote past, which he then called irrational and claimed to be outside science. But the idea, in its original form, wasn't simply that all of the universe's matter was created in one moment in the finite past. That notion, derided by Hoyle, had already evolved from its original meaning. Originally, the idea was that the universe itself, not just the matter within it, had emerged from a state of non-being in the finite past. And that idea, as wild as it sounds, was an inevitable but difficult to accept consequence of the new theory of gravity put forth by Einstein back in 1915, general relativity. When Einstein first cooked up the general theory of relativity, our conception of gravity forever shifted from the prevailing notion of Newtonian gravity. Under Newton's laws, the way that gravitation worked was that any and all masses in the universe exerted a force on one another instantaneously across space, in direct proportion to the product of their masses and inversely proportional to the square of the distance between them. But in the aftermath of his discovery of special relativity, Einstein and many others quickly recognized that there was no such thing as a universally applicable definition of what distance was or even what instantaneously meant with respect to two different locations. With the introduction of Einsteinian relativity, the notion that observers in different frames of reference would all have their own unique, equally valid perspectives on what distances between objects were and how the passage of time worked, it was only almost immediate that the previously absolute concepts of space and time were woven together into a single fabric, space-time. All objects in the universe move through this fabric, and the task for a novel theory of gravity would be to explain how not just masses, but all forms of energy, shape this fabric that underpinned the universe itself. Although the laws that governed how gravitation worked in our universe were put forth in 1915, the critical information about how our universe was structured had not yet come in. While some astronomers favored the notion that many objects in the sky were actually island universes that were located well outside the Milky Way galaxy, most astronomers at the time thought that the Milky Way galaxy represented the full extent of the universe. Einstein sided with this latter view, and, thinking the universe was static and eternal, added a special type of fudge factor into his equations, a cosmological constant.
That was it for now. For more content like this, subscribe to our channel.